Hi, welcome back to the channel. My name's PH, and this is day 15 of Structy, Data Structures and Algorithms course online, and we're going over the compress problem. Yeah, let's just jump right into it. As you can see, I did a lot of the pseudocode already, hence why this will be a shorter session today than usual. Forgot to add the and space complexity. I'm thinking of having to kind of like reorient my streaming duration time. I think that it should be a lot longer. However, due to like work and prior engagements, it's pretty hard to do that because usually these streams are like used to be like 2, 3, 4 hours, but now they're only about an hour. And I would like to do more problems in the future. Again, just having to work around my work schedule and schooling schedule, and with other prior engagements like, you know, doctor's appointments, whatever, it's going to be quite difficult. But yeah, enough of that. All right, let's just dive in to the problem. All right. So write a function compress that takes in a string as an argument. The function should return a compressed version of the string where consecutive occurrences of the same character are compressed into the number of occurrences followed by the character. Single character occurrences should not be changed. So if there's 3 A's, we should compress this to 3A. If it's 2 C's, 2C, T, and then just T. You can assume that the input only contains alphabetic characters. Right. All right. So I think first we are going to add a sentinel character. So, and we're going to add this to S. Now we're going to initialize results as an empty list because we want to be able to pass on the return statement to the problem and empty list. We're going to initialize pointers of I and 0, I and J for that matter. Because yesterday I was working on the for loops, and again, I think while loops in this condition are, in this case, are a better constraint to do instead of using a for loop. So, yeah. All right, let's continue. While J is less than the length of S. Oh, what am I doing? If S, if Si is equal to Sj, then we are going to increment J by 1. Else, we're going to calculate the count of the repeated characters. So num is equal to J minus I. If If the count is 1, append the character as I to result. If J is we're going to results, append, and we're going to else we're going to append the count and character. Oh, what am I doing? And we're going to move the pointer. Not move. By equal to J, I think. And then we are going to return the results. Think that is it. Sorry, checking something real quick. Sorry. What are you doing? BI. Yeah. So we're going to take S and we're going to increment it. We're going to add the exclamation point to it. We're going to have a result, and it's going to be an empty list. We're going to increment I, which starts at 0. The index of J also starts at this index of 0. We're going to use a while loop. We're going to go into J. Sorry, not go into J. We're going to increment J if J is less than the length of the string. If SI, if the indice of the list, sorry, not the list, the indice of S, which is the string, which would be this, is equal to that of J, then we should, then if that is true, then we should increment and go else. continue up. Sorry. If it's j, then we'll increment it, and then we will move on to the next one. If it isn't, then we'll take the num, and we'll take j minus 1. That's not minus 1. J minus I. And we're going to set that as the count. If the count is equal to 1, then we're going to append the value itself of j. And sorry, not j, I. And then if not, then we're going to append the string of the number, which would be the count. So, and then we would have to append the so yeah, we'll get this. So basically we'll get this and this and this. And then we're pushing all of these into this, and then we're going to return. And if this, we're going to reset the count to equal back to whatever I is. So, yeah. Ooh. Sorry, guys. I apologize. I am a little tired today. My thoughts are not as coherent as they should be. Let's move this up here. If this, I'm gonna print out the. So before it happens, so yeah, we get 3C, 3A, T3S, which would be because there are 2 C's, there's 3 A's, 1 T, and 3 S's. And it's just going to keep doing that for everything. So if I were to use a for loop in this case, I think that what would cause a lot of my issues again is because we're incrementing. I forgot what chat was saying yesterday, but it is, if I know the length of S, then it's better if I use this because it's much more controlled, versus if I were to use a for loop, iterating over that is going to cause a lot of more trouble because we have to keep up with the counts because we're for looping into 2 different, so the count is going to be off. And I think that's why you would prefer to use a while loop, because it'll just keep going until it ends. But for a for loop, it's like it's like within that constraint of that. And again, that it can mess up the count, and that's when there would be issues. And I think that's why there was a lot of issues with yesterday's code, because I was just like, it's like I think, or was it the day before? Just the for loops were not working. So if there's like a set number of, I think for loops are better for if you don't know the range of what you're doing, like you don't know how long it is. But if you do know the length of it, if you don't know the length of it, sorry, that's the opposite. I think because like S is, we have to determine what the length is. And that's why it's better with while loops. But if we want to increment to like 10, like just go from like, 0, 1, 2, 3, 4, 5, 10, then we could set that, and it's more, this, it would be worse to put that into the for loop versus this, because this is more, once it's over, it's over. So from my understanding, again, I could be wrong on this. So, yeah. In regards to time complexity, I'll go with space complexity first. There's not a lot of like pointers in memory that are like taking up a lot of space. So I don't think it's constant, but but we're not like having to go through like a for loop. So I think it's not constant, and I think it's linear. And I don't think it's forgot the one after that, after linear. I need it. So I think it's O of n, big O of n. And in terms of time complexity, because this is just space, we know the set length of the S. It's not like it's like an arbitrary number that we're like having to, or could it? No, I think it's O of n because it's not constant. It's not like we still have to search through things. So yeah, it's not constant. I think it is linear. Oh my gosh. All right. Let's try it out. Nice. Oh.
Hey programmers, Alan here. Now, right now I just want to cut into a little bit of your study time.
Let's put this back to like 1.25.
Hey programmers, Alan here. Now, right now I just want to cut into a little bit of your study time to do somewhat of a check-in as well as provide.
Why is it
concepts
still
that you
fast?
should be utilizing all of the resources in this course. And a lot of this was said at the very beginning of the course, but I think it's worth now reorienting ourselves, right, and reminding ourselves of those great habits. So over the years, I've had the great pleasure of teaching many people data structures and algorithms, right? And I've seen what has worked and been fruitful, as well as what has not worked and been very unproductive. Remember, for every single problem I give you, there's an approach video and a walkthrough video. And I really want you to use those videos liberally, right? So they're there for you to unstick yourselves and to really get the most out of doing every single problem. So
yeah.
The number one frustration that people have as they're learning data structures and algorithms, and even if I'm teaching them personally, is when I show them an algorithm, they feel like they could have never come up with that algorithm or that solution on their own. But in my opinion, that's totally okay and that's totally normal, right? So I think a lot of students have the wrong expectation. You have to remember, for even like experts who are good at data structures and algorithms, it's not like we came up with these solutions on our own, right? We learn them from other people, right? So as you're doing all of these problems, you should be leaning heavily on the videos I have in the approach as well as the walkthrough, right? Those are going to be where you really learn, right? My expectation is not that you should be able to solve the problem on your own and then you watch my videos afterwards, right? If you have to use the videos to understand the problem even, then you should do that, right? And I think going through the course in that way is really how you get the most out of it, right? What you should not be doing is like staring blankly at the screen for 2 hours before you look at a video of mine, right? Feel free to use the video if you're stuck for like 10 minutes, 10, 15 minutes. I think what's more important to do is after you've watched that video, you should have a high standard for yourself to see if you really understood it, right? So put the video away at that point and then try to code it up on your own. But if you get stuck again, then go back to the video, rinse and repeat. All right, so I hope you found that pep talk useful. Let's hop back into the course, and I want you to remember to be patient with your progress and also be unashamed to use all of these videos, right? Especially as you're solving a problem for the first time, right? I'm totally not lying to you guys, right? When it comes to learning data structures and algorithms, even in my own journey, someone had to teach me these things, right? So don't be too hard on yourselves. All right, let's jump back in.
Cool. Damn. We're almost done with... Oh. I want to do the quiz. What is big O time complexity of searching for a key in a dictionary? Oh, sorry. I was going to say this. Okay. My bad. I thought you would have, like, you have to click. Sorry, I'm stupid. I thought you had to like type in an answer, but I'm really tired, guys. Sorry. Click for an answer. Okay. Give an array of n elements. How many different types of elements can be formed in terms of big O? Give an array of elements of an array of n elements. How many different pairs of elements can be formed in? It's n squared because you can iterate through each. So if it's like 0 and then 1 and then 0, 2, 0, 3, 0, 4, and then 1, 1, 2, 1. Yeah. So yeah, I was right. Okay. Given an array of n elements, how many different triplets of elements can be formed in terms of big O? Triplets? Different triplets of elements can be formed in terms of big O. Given an array of n elements, how many different triplets of elements can be formed in terms of big O? I don't know, like I'm not sure about this question. Okay. I was gonna assume it's just you use qubit, but I was like, I don't think that's a. I think that's a stupid. Not stupid. I think that was like, I didn't think that would be that easy. If that was what I'm saying. Let's try this one. What is the big O time complexity of search for an element in a list? Searching for an element in a list. That would be O of 1. Big O of 1. It's O. Hmm. Oh, searching of an element in a list. Sorry, I was thinking of the basket. Sorry, like the book. I don't know why, because if I wanted like a box of books, then yeah, that would be O of N, because you have to like, okay, that's Moby Dick. This is Great Expectations. This is Pride and Prejudice. This is Dracula. This is Grapes of Wrath. Like, it's gonna take. Okay, I thought we were just like. Sorry, I should have. I hear this and then I didn't see like list. My brain is. Ay, ay, ay. Okay, so yeah, it would be O of N. What is the big time complexity of searching for an item in a set? Like O of N? It's N squared? What is kind of okay? What is the big O time complexity of searching for an item in a set? I thought sets were like hash maps. Wait, are sets hash maps? A set is similar to a hash map, but okay. No, that's my fault, because I thought sets were put both key and value pairs, but sets are kind of similar to hash maps, and they only store keys. So yes, it would be constant, because you're just. But wait, then okay, what's the difference between a list and a set? A list allows duplicate elements and maintains the order of elements within the collection, while a set only stores. Okay, all right. Because of their, because of like the abstraction of how they work, that is because like I'm just like, they both kind of like hold information, and they both, so like a list could be like a numbers like from like 0 to 5, and then if you had a set, then you would have keys of from like from 0 to 5. But I think in how they are searched through is, I'm kind of confused on these. Maybe again, I think it's just the level of abstracted, like the abstraction of how they work, their methodologies of how they work. But so I'm like 2, 4, 3. Two of wait 2, 4, 6. So I'm 2 of 6. Sorry, my bad. Because I got this one right. Wait, which one did I get right? I didn't get this one right, but I got this one, and I just thought it was like, oh, it was kind of simple. Yeah, I'm 2 of 6. So, oops. Oh no. Wait. According to Alvin's advice, should you avoid watching the approach and walkthrough videos when you are struggling? No, you should not avoid them, because staring at the screen and not solving them is much more of a waste of time and mental space. Again, the complexity of staring at a screen, you're just like, I'm wasting time and I'm wasting my mental fortitude. just by staring at a screen for 2 hours. So obviously look at the approach and walkthrough videos. I've been using the approach videos much more than I am doing the walkthrough, because like I think Alvin kind of just like explains things in much, like he basically gave me this structure and then I wrote the pseudocode for this. If you guys were wondering. So yeah. Yeah. Hmm. Let's show. Oh. Okay. Should I be going through this? Because I still have two problems. I shouldn't go through this. Well, fuck it. I'm curious as hell.
A little run through some array and string problems. We covered how to use the two-pointer strategy as well as using a hash map and hash set. We're going to revisit array and string problems all throughout the course. This was just a light introduction to get us warmed up into our next few topics. Don't worry, you'll get more opportunities to practice this concept as we go further in the course.
Okay. All right. See. All right. So we have two more, and we're going to not be done with arrays, but we will know a little bit more than we did. Again, I still need to go through all of these, either using a while loop, a for loop, enumerate. Is enumerate method similar to a hash map? No, enumerate is not similar to a hash map, although both involve associating values with keys. Okay. Yeah. Yeah, I want to learn how, like, what is the most efficient way of doing this? Because as of right now, it was either for loops or while loops, and then going through an array. Yeah. Let's see. It's only been 27 minutes. Okay. Maybe I might cut it here. Yeah, I should. Yeah. Oh. Let's just look. So beginning of recursion, linked lists, binary tree, graphs. I don't want to start a new topic, and if I don't, so yeah, I might just go back and do all of these again and try to be solved, like have them solved by like different like lists, dictionaries, while loop, for loop, enumerate. Yeah. And these two. What was I doing? My brain just wandered. Yeah, I really do like this course. It's much more simpler than NeetCode. NeetCode's going to be its own beast in itself later down the line, because we're already 2, 2, 4, 6, 8, 10. We're a fifth of the way. So, yeah. This took that many days. I think by the... How many? So there's 9. Wait, no. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 30, 31, 32. Okay, this is going to be maybe because if at the rate I'm going, I'm doing like one problem a day. And again, my stream should be way longer than this. So maybe I should start doing 2 or even 3. Yeah, like an hour per problem. Sorry, not an hour, but like a thorough hour for each problem, like doing it all. So, like I was saying earlier. Oh yeah, we never checked if I was right. Which one is that? Oh, yeah, I was right. Okay, guys. Again, thank you guys so much for watching. There'll be a lot more less roadblocks than last week, and I will continue to do this every day. That is the plan. Sorry, not every day. Every 6 days out of the week, and we'll just keep continuing to do so. Hopefully, no more fires happen again. I hope everyone's safe over there. Like, I think 10 people died so far. That's unfortunate. I haven't really checked as of late, but yeah, my power issue is no longer an issue. And yeah, I will be here tomorrow. All right, guys. Thank you so much for watching, and I will see y'all tomorrow.